left.
Okay, so let me share the screen. So Ajay, Audrey's book you have to read, okay?
Okay, sir.
Means first
I have
chapter.
actually I was asking about that. Which book will be better for statistic?
Because Audrey's will answer very important questions, okay? Means the books are very high quality as well as also from our perspective very technical questions. Both Gujarati and Audrey's will be sufficient, okay?
Okay, sir.
So let me see where it is. Okay. So today, what we will do is we'll do a review of fundamentals of probability will complete. Okay. Is it clear, Ajay?
Yes, sir.
Okay. So there are 10 pages. So some of the things if I have already discussed, so I will try to omit. Okay, so that we can complete this note. I hope this is already there on the Google means Google Drive also. I will post it on the OneDrive as well. Okay.
Okay, sir.
So random variable already we know the number of spots showing on a single throw of a throw of a six-sided die, where you have six possible values, right? Spots basically, right? So these are the different examples. Corn yield on a plot of land with a particular fertilizer dose. Return on the S&P 500 index tomorrow, or Nifty 50 index tomorrow. Suppose problem sets are assigned every week, but whether a particular set will be collected for grading is determined by a coin flip. The number of problem set collected for grading in a week is a random variable. The number of problem set collected for a grading in a 15-week semester is also a random variable. So it is the sum of the 15 random variables. Okay. So these are the basically different examples of random variables. Okay. Now the definition is a random variable is a function whose value is a real number and which is determined by each element among all possible outcome in an experiment. Okay, Ajay, please write it down. Huh? A random
Okay, sir.
variable is a function whose value is a real number determined by each element among all possible outcomes in an experiment. Because very few people they know what is random variable. Okay, they will say that a random variable is something where the outcome is uncertain, like that. But basically it is a function whose value is a real number and it is determined by each element among all possible outcome in an experiment. Clear? Ajay, is it clear?
Yes, sir.
So as already we know, we have discussed random variables may be continuous or discrete, right? Continuous is corn yield, daily return on the Nifty or S&P 500. So which is basically we assume that if it is continuous means it will follow normal distribution, and if it is discrete means coin flipping a coin and to roll a die, correct? In which case one can list all possible values. Is it clear, Ajay?
Yes, sir.
Or do you have any questions? You can ask me.
No, sir.
Okay. So now examples of probability distribution for discrete random variable already we have discussed. Like dice game 1. Let x be the number of spot on a single throw of a six-sided fair die. So this is the random variable, and this probability of x taking the value of small x, that is the specific values of the random variable, right? So what is the random variable as here?
Small x, sir, to get
No,
1, 2,
no,
3,
no, no,
4.
no, 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 no. Random variable is x is the capital X is the number of spot. This is the random
Sample
variable.
space.
Number of spot on a single throw of a six-sided fair die. Okay.
Yes,
Small
sir.
x is the specific value. Correct. Are you getting my point?
Yes, sir. So
So
what would be random variable? Oh, which one?
random
For a
variable is this one is random variable. RV.
capital X, sir.
And this
Oh,
is specific values of the random variable.
okay.
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 When the random variable takes the specific values. Okay. Right. Next example is dice game 2. Throw two pair dice. Let x1 be the sum of the spot on dice 1 and x2 is the sum of the spot on dice 2. So the table below represents basically present the probability distribution for the random variable. W is equal to x1 plus x2. Okay, Ajay? Is it clear?
Yes, sir.
Means you are having die 1, then you will throw die 1 and then you will throw die 2. Okay?
Die 2.
And
Then
here W is basically
the random
uh,
variable
addition of
x1 plus x2, or basically
plus
die 1
x2. Die
output
1
plus
plus die 2.
die
Okay?
2.
So suppose for example it is saying W is equal to 2. So 2, how many number of cells are there? You can see 1 means 1 plus 1 2, isn't it? So probability of W taking the specific values of Wj, that is 1 by 36. Yes or no? Okay.
Yes, sir.
So there is no issue, right? Or is there any problem?
No, sir.
Next example. So when we toss a coin with probability of head is equal to theta and probability of tail is equal to 1 minus theta. Okay. To define the random variable x to be the number of head, which is basically success in the n tosses or the trial of the coin. Okay. So basically how we will write? We will write like this: probability of x equal to a, taking the value of small x, which is equal to n factorial upon x factorial into n minus x factorial into theta to the power x into 1 minus theta to the power n minus x. Clear, Ajay? This one?
Yes, sir.
Okay. Now you see.
Sir, what is x factorial? X factorial into n minus x factorial.
Ah. So whatever the value will be there, okay. Accordingly, we will decide, na. You will see over here. Okay.
Okay.
There is one calculation.
Sir,
Yeah.
hello.
Yes, Madhusudhan.
Sir, I am unable to understand how px is equal to x is equal to n factorial divided by x factorial n minus x factorial. This part.
Okay, so it is a good question. So means you have never came across this term, or means
Sir, I know the factorial, but
okay,
in this case, I do not able to relate it.
okay, no issue. I will explain. Okay, give me a minute. Earlier, I think you have not joined. So you have joined means it is good. We will get some good questions.
Sorry, my question is always in basic level.
No. These questions are very important for understanding. Because if someone will ask, then only others will try to understand. Because otherwise, people will think that it is just because I will go fast. Are you getting my point?
Yes, sir. Yes.
Because as we are, one second. So this is a binomial probability formula. Do you know it or not?
Sir, binomial probability.
Hmm.
No, sir.
Binomial means what?
Sir, binomial means more than if we have a more than two variable or
Yeah, binomial. Like when you are tossing a two coin, binomial, right?
yes, sir.
So this is basically see when you are like for example, suppose when I am throwing a coin. So there are two possible, right? One is head, second one is tail. Yes, so there are two values only, two possible values.
Yes, sir.
Okay, so
Yes,
the
sir.
total probability is one. Okay, suppose head, head is, let's say that if I take head as theta, okay, theta is
Yes, sir.
any value, okay, because it can be like 0.5 also, you can write, not a problem. So now theta is any value because already what I have defined. Random variable is a function whose value is a real number determined by each element among all possible outcome in an experiment, right? So this is a random variable, isn't it? So
Yes,
head is equal to theta, probability of head is equal to theta, then probability of tail will be how much? Because already we know that the maximum probability will be 1. So it will
yes,
be
sir.
1
One
minus
minus theta.
theta.
Yes,
Okay.
yes,
So that is why we have defined the random variable, that is x is our capital X is a random variable, that is number of head. Head is success. And
Yes, sir.
in the n toss, if that is called also trial. If you are doing n tosses, so how many number of heads, which is success basically, failure means 10, you will get. Clear?
Yes, sir.
So basically, as I told you, so this is the probability mass function. What it is? The
Probability mass.
probability mass function. So here, what else you want to know? Means, is there any means you want to know why you have written, or suppose let me explain it. Okay, this
Mm.
formula, first of all, this is PMF. Okay, probability mass function. So you want to know what is probability mass function or what? Probability mass function already I told na earlier also.
Yes, sir.
So what is probability mass function?
Sir, basically we have two type of function: probability mass function and probability density function. If we consider the discrete data,
Hmm.
then we use the probability mass function.
Okay. So please write it down. Please write it down. Let me tell you something.
Okay.
A PMF is a function. Is a
Function.
function that gives that gives the the probability that a discrete
Discrete.
random variable takes on a specific value. Okay, that a
Yes, sir.
discrete random variable takes on a specific value. Is it clear?
Yes, sir. Yes.
Suppose, for example, let me clarify it further. If x is a discrete random variable, or we will say in short, it is a DRV, discrete random variable.
Variable.
So, what will be its PMF? Its PMF will be probability of x taking the value of small x, okay, or we say which is equal to f of x. Okay, clear?
Yes, sir.
So especially it is giving you idea that what is the probability that x equals exactly small x.
Mm.
Are you writing it down?
Yes, sir.
Means the PMF is telling you what is the probability that capital X equals exactly the small x,
Small leg.
or when the capital X takes the specific value. Okay,
Yes, sir.
clear?
Yes, sir. Yes.
Suppose, for example, hmm, if you have remember, we did I told you a experiment, that is tossing a fair coin twice. Okay,
Yes, sir. Yeah.
if I am tossing a fair coin twice, in that case, so basically, if we'll take the x as a number of
Head.
head, you asked me also that day also one question, number of heads. The possible values will be 0, 1, 2, isn't it?
Yes, sir. Yes.
I did not TT, TH, then HT, isn't it?
Yes, sir.
And uh, head is also possible, isn't it?
Mm-hmm.
Head is also possible, right? 2 to the power 2, na? 4.
Yes, sir.
So now, if I'll ask what is the PMF, okay? So you have to represent in terms of a table, okay?
Mm-hmm.
So how you will write? You will write the specific value as small x. Then you will write probability of x equals to small x. So you will write the specific value 0, 1, 2. 0, what is the probability? That is 1 by 4. Tell, isn't it?
Mm-hmm. Yes,
So
sir.
that is 0.25. You will write. Okay?
Yes, sir.
Then 1, you will write 0.50. Then 2, you will write 0.25. Because number of head will come head only. That is also 1 by 4. Isn't it?
Yes, sir.
Clear?
Yes, sir. Clear,
And,
sir. Actually, you
and
already
huh? Huh?
said this concept already you taught us.
No. I have already taught you, but it should be very simple so that you will be able to understand.
Yes, sir.
And this is first of all, you write TT. This is TH and HT. And this is only head. Okay? That is why. So this will be definitely 0 because we are taking the number of head only success. Okay? And this is 1 because 2 by 4. 2 by 4 is 1 by 2. That is
1 by 2.
0,
Yes, sir.
0.50.
Fine.
Again this is also 1. So 1 by 4 is 0.25. Clear? So
Yes, sir.
this is basically your PMF when you are doing a tossing a fair coin twice. Okay? So always you should know there are two essential conditions for a valid PMF. What is that? If you will remember that, then you can construct this table.
Yes, sir.
PMF table. First one is probability of x equals to small x or specific values is greater than equal to 0. It means probability are non-negative numbers. Okay? Isn't it?
Yes, sir.
Second, summation of px taking the value of small x will be equal to 1. Means if you will take all the probability of specific values of x, so it will add up to 1. Suppose for in this case, you just see, you will add 0.25, 0.25 plus 0.50, it is 1. Then it is satisfying. First property is also already satisfying. That it
Yes,
is greater than 0, positive number, isn't it?
Yes, sir.
This is how you will remember. Then you understand, then you will never forget. Okay?
Yes, sir. Yes.
But in binomial PMF, what you will get is basically that is a formula. You can just remember like that, which will give you idea about probability of getting exactly X success in n trials. Okay?
Sir, can you again repeat probability of?
I am telling you, in binomial PMF,
Yes, sir.
is basically it is a formula. It is a
Formula.
formula that tells you that
Tell.
tells you
Yes.
the probability of getting exactly X success, the probability of getting
Exactly X success.
X success in N trials.
In
In
trial. N trial.
in N trials. You just see probability of exactly getting X head in N trials. Head is your success.
Hmm.
Okay.
Yes, sir.
Now this formula is basically comprised of three parts. Okay. This is very
Yes.
important to know.
Yes.
First is already we have studied, that is called binomial coefficient. Okay.
Hmm.
This is called n factorial
Binomial.
upon x factorial into n minus x factorial. This is also, if I remember, it is also written as like this, n x, isn't it?
Hmm. Yes, sir.
So basically this is giving you the number of ways to arrange x success among n trials. Okay. Suppose for example, if n is equal to 3 and you want x is equal to 2, then the arrangements will be SSF, SFS and FSS. So it will be like this, 3 2. Okay. So basically
Yes.
it will be 3 ways you will get. You just write it down, you will be able to see.
Yes, sir.
It will be like SSF, success, success, failure. Then success, failure, success. Then failure, success, success. Okay. So, okay, Madhusudha.
Yes, sir.
So theta x is basically theta to the power x is probability of getting exactly x success. Okay.
Yes, sir.
And 1 minus theta to the power n minus x is basically probability of getting the remaining n minus x failures. Okay.
Sir, N minus X means?
Let me write it. There are a lot of things are here. Okay. And this 10-page PDF is very important for you. I'll write it somewhere. Let me write it here. So first part is already I told you. What is the first part? That is binomial coefficient, right?
Copy.
Binomial coefficient. That is n factorial upon x factorial into n minus x factorial.
Expect.
We also write like this, n
X.
x factorial. Directly we write like this, okay?
Yes.
Second is theta to the power x. That is probability of getting P of getting exactly x success. Exactly.
X.
Third, one minus theta to the power n minus x is basically the probability of getting the remaining n minus x failure. Okay.
Yes, sir.
The probability of
Getting
uh,
remaining n
probability
minus
of getting
n minus x failure.
n minus x failure.
Yes.
With success already we have calculated, na?
Yes, sir.
So out of n trials, x already you have calculated.
Yes, sir. We have a formula also, sir.
That's
Success
it.
failure
That's
is
it.
equal to 1.
That's it. You just see.
Yes,
Suppose
sir.
now let's say that you have thrown a coin, okay, fair coin, okay. In that case, theta will be 0.5. Yes or no?
Hmm. Hmm.
Then if I will ask, what is the probability? What is the probability of getting exactly exactly two head in three tosses? I will find. You will write like this: probability of x taking the specific value, that is 2. Okay. So then 3 factorial
3 factorial,
divided by 2 factorial into
3 minus 1 factorial.
1 factorial. 3 minus
Yes.
2
Yeah, yes, sir. 3 minus 2.
into 0.5 square into 0.5 to the power 1. Clear?
Yes.
सर x to the theta to the power x जोड़ा थिला सेटा 2 कौन हैला theta to the power x
0.5 ना, theta is 0.5 ना, अजय.
yes sir हाँ
तो theta to the power x, isn't it? We are saying the
X
question
is
is
2, sir. So 2
yes sir
probability of exactly getting 2 head. So theta to the power x na. X is our random variable. Are you getting my point?
yes sir okay
Madhusudha?
yes,
in
sir. Yes.
place of x we have substitute the value equal to 2
Correct.
2 factorial means 2 into 1 means 2. First we take the 0.5 to square, and after that we take 0.5 1. It means power 1.
Yes, yes. So how you got 0.5 to the power 1? Is it clear?
Hmm.
How?
Yes, sorry. As we mentioned, 2
Because,
factorial.
because it is
1 minus theta equal to 0.5 that means 0.5 and n minus x is
n is 3. 3 to the
n is
3 minus
minus
2. That is 1.
2
Very
that
good.
is 1
Very good. Very good. Very good. So now it is how? What will be the final answer? 3 factorial upon 2 factorial into 1 factorial is how much? 3, right? Then into 0.5 square is how much?
0.
2.5 sorry
Ajay?
0.25.
0.25 sir
Don't do it. Then into 0.5.
0.5.
Then you multiply. How much it is coming?
Sir, final answer is 0.375.
How much?
Sir, final answer 0.3375.
Okay, 1 second. Yeah, 0.375. Okay, 0 point. You got this, right?
Yes, sir.
Okay, very good, excellent. Ajay, have you understood? Now you just remember in this case, yeah, have you understood?
Yes, sir.
So two important properties of binomial distribution, Madhusita, you should understand. First is what is the mean value? Mean or expected value. That is expected value of x will be equal to n into theta. Okay, average value. N into
Theta.
theta. And variance will be, because always you should know variance and mean. So variance will be n theta into 1 minus theta. Okay.
Yes.
So this is very interesting. Okay. Isn't it? So what you can do, Ajay, you have understood or not?
Which one, sir?
No, what we are doing today? Just Madhusida asked now, what is probability of x? Then we derived so much, isn't it?
Okay, this formula I have got, sir.
Okay.
I
Then
have understood.
I have explained what is PMF. Then I
Yes.
have explained,
How to formulate the PMF table.
yes.
Sir,
So
I have a basic doubt again.
yes,
Small
please,
doubt.
please ask me. Please ask me. Please ask me.
Sir, as already several times remind us, the expected value means what? What is expected value?
Expected value is average value. On an
Yes, sir.
average.
On an average value.
Suppose we say on an average, means in this case, if you are doing n trial, on an average, what is the success of getting head?
Yes, sir.
Okay, so it will be n into means theta. Means let's say that if you are doing 15 trials, so it will be 15 into 0.5. That is how much, Ajay?
Sir?
Theta is 0.5.
Yes.
If you are, let's say that doing 15 trial, means you are 15 times you are throwing the coin.
Yes, sir.
Then what is the probability of getting actually, what we will say? Means what is the average? As Madhusudha asked, what is the average number of probability of getting any success? How you will get? 15 into 0.5. So how much it is? Are you
Seven
getting?
point 7.5.
7.5. So it means it is looking fair, na, Madhusudha?
Yes, sir.
So obviously, so that is what expected value is. Actually, I hope it is clear, right?
Yes, sir. Clear, sir.
So now what you do is
Value
you,
or average?
because I am sure when somebody has might have taught you probability mass function, then they have to clarify your doubt. Then only it will be clear. Now what you do is you calculate this in Excel.
Okay, sir.
Then it will be interesting. This table, please complete it in Excel.
Hmm.
Okay. Then you
Yes, sir.
see, because what is X? X is basically theta, already you know, right? Theta is 0.5. Now it is saying let the random variable X equals to the number of head in the 6 tosses of a fair coin. Okay? 6 tosses of a fair coin.
Fair coin.
You are doing
And
six tosses. So if you will increase into how many tosses? Let's say that we will increase into little more than 30, then what will happen we will see. Okay, but at least 6 tosses of a fair coin when you are doing. So n minus x you calculate, then n minus x factorial you calculate, n minus x factorial, then n factorial upon x factorial into n minus x factorial, then theta x into 1 minus theta to the power n minus x, then probability of x equal to x. Okay, is it clear?
Hmm. Yes, sir.
So basically when you will do like this, so this is basically the probability distribution you are
sir,
calculating.
I have a doubt that this first column is small x and
Small x,
the
small
last
x.
column is probability of x equal to small x.
Ah,
So what is that means? Both are the same or the difference, sir? These two values are
where?
the first column, sir. 0, 1, 2, 3. What it signifies?
This shows getting one head, getting two head, getting zero head.
X specific value, sir.
Ha, yes. One head,
Then
two head, three head, four head, five head, six head.
okay.
Are you getting?
The capital X represent the event and small x represent the specific value of
Correct,
the.
correct. Yes, yes. Okay, clear?
Yes.
Yes, sir.
So then you calculate. Okay, and that then you show it to me. Vasudha, you can calculate it,
Okay, sir.
and then what we can do is like then we will do the next joint distribution, conditional distribution, and the concept of independence.
Okay.
Tomorrow I will finish this one, like marginal distribution
Hmm.
and some other important properties. Then I will give you another assignment. Already one assignment I have already given you, isn't it? Practice problem set 1. Madhusudha, are you aware about
No,
it?
yes, sir. You uploaded.
On OneDrive.
Right. Yes, sir. You're on drive.
Okay. So tomorrow again we will resume our discussion. So please complete this task on Excel. Okay.
Sir, yesterday, what are the things I discussed? Just tell me. So
I have a recording. I will send it to you.
Okay, sir.
That will be better.
Okay.
Okay.
Yes, sir. Thank you.
So I am going slow because this is very important section. Okay.
Yes, sir.
Because probability again we are just completing it. Then we will focus on joint distribution, conditional distribution, and the concept of independence.
The joint distribution and joint probability is the same thing or different?
Yeah, same.
Yes, sir.
Okay.
Yes.
I will send you Madhusudha this one.
Yes, sir. Thank you.
Thank you. And also